We're now going to talk about some of the operators that Rust supports. So let's make a function for precisely this. It's called operators. So operators are things like plus, minus, percent sign, these funny little symbols that you use to actually do something. So function operators. There we go. Okay, so well, some of the simpler arithmetic operators that we're going to start with. So arithmetic, first of all. So for example, if you have a variable, I'm going to make a mutable variable called a, you can give it a value 2 plus 3 times 4. So the operators are things like the plus and the multiplication. Now here, as you can imagine, the typical arithmetic operators, plus, minus, multiplication, and division, they all follow precedence, meaning that multiplication here is going to be done before the addition is done. So this is going to have the value of 14. We can actually, let's just print it out for completeness sake. So just print it like this, a. Right, let's run this and see that it is in fact what I'm claiming it to be. Here is the value 14. You'll notice that we got a highlighting for the other functions saying, oh, by the way, you're not really using this function. Why are you even including it in the source? So let me move this down so it doesn't distract us. Okay, so let's talk about changing the value of a, because you see we have an inspection here saying variable does not need to be mutable. You're not really changing it, so let's change it. Let's imagine that I want to increase the value of a by 1. What I can say is a equals a plus 1, just like that. You'll notice that unlike many other programming languages, Rust does not support the minus, minus, and plus, plus operators. So unfortunately, if you want to increase the value by 1 or if you want to decrease it by 1, you cannot use these. You have to say a equals a plus 1 or a equals a minus 2, for example. So, but if you are a bit lazy and you want to, say, decrease the value of a by 2, you can write it like this, a minus equals 2. So this is the functional equivalent of a equals a minus 2, just a bit quicker. And as you can imagine, you have similar operators. So you have minus equals, plus equals, times equals, divide equals, and also percent equals. So we'll talk about percent in just a moment. Oh, actually, let's talk about it now, because essentially the percent operator in Rust gives you the remainder of the division. So right now, the value of a that we have is what, 14 plus 1, 15 minus 2, so it's 13. So the remainder, let's do a remainder of the division of 13 by something else. So remainder of this divided by this is equal to this, and we try to divide a by 3 and calculate the remainder. So the remainder would be a percent 3. So the percent here means that we take the remainder of the division of a by 3. So 13% 3 should be equal to 1. And if we run this, well, that's exactly what we're getting here. So no particular magic here for now. And incidentally, there is no power operator, which is a bit disappointing, because if you want to take a to the power of 3, for example, you have to do it using the built-in functions. And I know this has nothing to do with operators, but let's just take a look at it because it's rather important in the context of, you know, arithmetic and math generally. So if I want to calculate a cubed, I would have to do it like this. I would have to say I32 colon colon power a3. So this basically does a times a times a, but it does it in a kind of implicit way, in the sense that I simply use this function, which is part of I32, and I give it a and which power to raise it to. And let's print line that just for the sake of completeness once again. So a cubed is equal to this. So a and a cubed. There we go. Let's run this. So 13 cubed is 2197. I'm going to assume that's correct. Okay. So this is how you take the power of something, but sticking with this idea of taking the power of something, it actually gets a bit more involved than it does in other programming languages, and you might want to watch out for this, because the language makes a distinction between the power, which is integral, which you can do by, you know, recursive multiplication, and the power, which is not integral, where you build Taylor series, and it becomes a lot more expensive to calculate. So for example, let's say we have b having the value of 2.5. Now, if I want to cube this value, if I want b cubed, for example, then what I can do is I can use F64 because that's the data type that B is. We've talked about it in the previous clip. I would use pow I, and the I here stands for the fact that the power is integral. It's an integer. It's not a floating point power. It's a whole number basically. So I specify B and the value of 3. So this just does B times B times B, which is, you know, reasonably efficient. Now, if I want to take B to the power of pi, for example, so B to the power of pi, I would do it like this. So I would use F64, but here I would use pow F. So F stands for floating point. So the power is not going to be a whole number, and you have to build this, e to the power of log with the base x and the value of y. That's how they calculate power in the computer, actually. So here we specify b, and the power is pi. So we want to take pi from the standard constants for F64. So the way you do it is you say std F64 constants and then pi. You'll notice the constants are always capital. So that's how you take the constant of something. And then let's print out these values. So let's do a print line. So pi cubed is equal to this value, and not pi cubed, 2.5 cubed, or b cubed is equal to this value, and b to the power of pi is equal to this value. So now I'm going to have b cubed, then b again, and b to the power of pi. And rest assured that this will give us the right values. So 2.5 cubed is 15.65. That looks kind of sensible. 2.5 to the power of pi looks 17.79. So that's okay once again. So this has nothing to do with operators as such, but it was just an important thing for me to mention because, well, you might want to take the power of something. So these are some of the arithmetic operators, fairly obvious stuff. Now let's talk about bitwise operators. So as you know, integers and indeed floating point numbers, they're made of bits. But in Rust, bitwise operators are only available for integers. So what you can do is you can write something like let C equals 1 or 2. Okay, so in the sense, the vertical bar is the OR operation. The ampersand is the AND operation. The hat is the XOR, the exclusive OR operation. And the exclamation mark is the negation operator. So in this example, we can take 1, if I ignore the leading bits, 1 would be a 0, 1, and then 2 is a 1, 0. So we end up with 0, 1, or 1, 0, which is equal to 1, 1, which is equal to 3 in the decimal system. So we should get the value of 3. Let's actually print it out once again. So 1, I'm just going to print it 1 or 2 equals, and then the value of C, and that should give us a 3. And that's exactly what we're getting. So these are operations which happen on bits. You don't need them too often. And in addition, yes, you also have the shift operators. That's when the entire contents of the number gets shifted left and right a certain number of places. One of the common uses is calculating, let's say, 2 to the power of something. So if I want to calculate 2 to the power of 10, then I would take a 1 and shift it 10 places to the left, and then we can print line this again. So 2 to the power of 10 is equal to 2 to 10, should be 1024, I believe. Yes, that's exactly what we get. So shift, and once again, this is a shift to the left, and similarly, you have a shift to the right. Okay, so these are some of the bitwise operators, and then of course we have the logical operators. So for example, let's suppose I want to find out whether pi is less than 4. So let pi is less than 4. So I can compare the values of pi and 4 and see whether one is less than the other. So I would say something like stdf64 const pi less than 4.0. So this would give me a value of true because pi is in fact less than 4.0. And similarly, I've used the less than operator to compare the left and right hand side. Similarly, you have the greater than operator, and you also have less than or equal and greater than or equal operators. Now, if you want to compare two values for equality, then you use the double equals. So for example, if I have x equals 5, for example, then if I want to check if x is 5, let x is 5, I can do it like this. I can say x double equals 5. So this compares the left and right hand sides, and obviously it returns true if this equality holds, and it returns false if it doesn't hold. So in this case, the value would of course be equal to true. So this is a brief overview of the operators. We might meet a few more operators down the line, but these are the basics, and we're going to be using all of these operators quite a bit.